question number 11 of the worksheet, which says, find the number of ways in which all 12 letters of the word refrigerator can be arranged if there are no restrictions. So arrangement means permutations. Part A, no restrictions. So these are 12 letters. So that's going to be 12p12 or 12 factorial upon how many repetitions do we have? We have R, 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 and R. So 4R, so 4 factorial times E is there twice. So times 2 factorial times anything else that is repeating. I guess not. So it would be 12 factorial upon 4 factorial times 2 factorial or 12p12 4p4 times 2p2, and that would give 181440. Part B says how many arrangements are possible if the R's must be all together. Must all be together. Okay, so now we're going to group the 4 R's. 1, 2, 3, 4. So for now, let's ignore that it's the same letter. So we're going to say 4 spaces, 4 alphabets. So that's 4 factorial arrangements. So we're going to consider this as one group of one alphabet. And we know that its arrangements are 4 factorial. Okay, so if we remove 4 R's from the list, then we have 8 more left. So 1, 2, 3, 4, 5, 6, 7, 8. 8 of the other alphabets, and this is considered as one alphabet. So that's going to be 9 factorial or 9p9. 9 factorial times 4 factorial, and then considering the repetitions, 4 R's are being repeated and 2 E's are being repeated. So divide that with 4 factorial and 2 factorial. So the answer is oops, this was the answer for this part. My bad. It's 181440. And the answer for this part is 9979200. Okay, question 12. The 6 digits 456777 can be arranged to give many different 6-digit numbers. How many 6-digit numbers can be made? So again, it's a question on arrangements. That means permutation. So 1, 2, 6 letters, 6 spaces. 6 digits, 6 spaces. So that's 6p6 or 6 factorial. I'm writing 6 factorial upon we have 3 sevens, 3 repetitions. So divided by 3 factorial. That is 120. Part 2. How many of these 6-digit numbers start with an odd digit, end with an odd digit? So 1, 2, 3, 4, 5, 6. This should be odd. This should be odd. So how many odd numbers do we have here? 1, 2, 3, 4. So we have 4 contenders for this spot. And then if one odd number is already taken, we'll have 3 contenders for this spot. Can also say 4p1 and 3p1. That's also 4 and 3. And then 2 digits have been taken and 4 are left. So in between, it's going to be 4 factorial or 4p4. It's It's going to be 4 times 4 factorial times 3 upon repetitions, which is 3 factorial, because there are 3 sevens. This equals to 48. Next. Question number 13. Part A. In a sweet shop, 5 identical packets of toffees, 4 identical packets of fruit gums, and 9 identical chocolates are arranged in a line on a shelf. 5 toffees, 4 fruit gums, and 9 chocolates are arranged in a line on a shelf. Find the number of different arrangements of the packet that are possible if the packets of chocolates are kept together. Okay, so we're going to keep chocolates together. So that's going to be 9 chocolates. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 chocolates, 9 spaces, 9 factorial. We're going to consider this as 1 chocolate, 9 factorial. And there are 5 toffees and 4 fruit gums. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Now we have to arrange these. So that's 4 plus 5 plus 1. So that's 10 spots for 10 candies. So 10 factorial. And there was the first group, or the first candy has 9 factorial arrangements. And divided by repetitions, we have 5 repeated toffees because they're saying they're identical, 4 repeated fruit gums, and 9 repeated chocolates. So this gives 1260. Part B. Jessica buys 8 different packets of biscuits. She then chooses 4 of these packets. How many different choices? Chooses means combinations. How many different choices are possible if the order in which Jessica chooses the 4 packets is taken into account? Okay, so if the order is taken into account, then it's permutation. This is permutation. So it matters if it's chocolate and strawberry or it's strawberry and chocolate. They're considered as different arrangements. Okay, so how many different choices are possible if the order in which Jessica chooses the 4 packets is taken into account? So there are 8 packets, 4 available slots. So that's going to be 8P4. Which is 1680. Okay. The 8 packets include 1 packet of chocolate biscuits, 1 packet of custard cream. How many different choices are possible if the order in which Jessica chooses the 4 packets is taken into account? So again, order matters. So again, it's permutation. So although the question said chooses at the start, but that did not mean that this was a question on combination, because later it said that order mattered. Usually if it's chosen and selected, it's confirmed that it's a question on combination. But this is a rare question in which later they say that the order matters. So now it's permutation, not combination. So you have to be very careful about what has to be found, the permutations or the combinations. Okay, so let me reread part two. Okay, there's one packet of chocolate biscuit and one packet of custard cream. How many different choices are possible if the order in which Jessica chooses the four packet is taken into account and the packet of chocolate biscuit and the packet of custard cream are both included? Saying que chocolate biscuit, we have one chocolate biscuit that has to be chosen, and then we have one custard cream biscuit, and then you'll have uh, two more biscuits that have to be chosen out of six available biscuits. So this is a question on permutation. So the order matters. So this chocolate biscuit can't just be placed at the first spot. It can be placed in the first spot, it can be placed in the second or third or fourth. So if we're choosing to select the chocolate biscuit first, we're going to say that this is one chocolate biscuit and it has four spots available. So it's going to be 4P1 combinations. Then one of the spots has been taken. Now there are three spots available. And if we're choosing this next, then this one biscuit, one custard cream biscuit has three spots available. So that's going to be 3P1 combinations. So now another spot has been taken. Now there are two spots left for six available biscuits. So that's going to be 6P2, and that gives 360. Okay, part C. Nine different food pies are to be divided between three people so that each person gets an odd number of pies. Find the number of ways this can be done. Nine different food pies are to be divided between three people so that each person gets an odd number of pies. Find the number of ways this can be done. Three people, they need to get an odd number. So odd number क्या हो सकता है? One of them gets one pie, another one gets three pie, and one gets five pie. Yeah, that's an odd combination that could work. And what if one person gets one pie and another person also gets one pie and the third person gets seven pies? That would also work. What about one person gets three pies, the other person also gets three pies, and the third person gets कितने थे total 9, so 3. So that could also work. Any other combination that could work. In fact, it could also be 171 or 711. Similarly, it could be 315 or 351. 333 तो यही रहेगा. Could be 135 or 315 or 531 और भी हैं इसके. In fact, 8 होंगे. Because अगर हम बेसिक काउंटिंग प्रिंसिपल यूज करें तो इसमें 135 में से कुछ भी हो सकता है. सो 3 और फिर अगला 2 और अगला 1, तो 6 होंगे. सॉरी. So 6 ways of writing this, 3 ways of writing this, and just 1 way of writing this. 6, 3, and 1. Okay, so I'm going to do 117 first. Just 117. First person gets one pie only. So there were total 9 pies. So this is going to be 9C1. The next person gets one pie, and now there are 8 available pies. So it's going to be 8C1. Next person gets 7 pies. It's going to be, sorry, one pie. Sorry, next person gets 7 pies. And there are 7 pies left. So it's going to be 7C7. And since there are 3 such combinations, there's also 171 and 711. So we multiply the answer with 3. Now I'm going to consider 135. That one of the person gets one pie, another gets 3 pie, another gets 5 pie. And like I said before, there are 6 ways of writing this. So I'll multiply the answer with 6 in the end, times 6. So if the first person is getting one pie, there were 9 available pies, so 9C1 times the other person gets 3 pies, there are now 8 available pies, so 8C3. And then the last person gets 5 pies, and there are 5 available pies, so it's going to be 5C5. One pie इधर select हो गया, 3 pies इधर select हो गए, so ये 4 minus 9 is 5. That's why I was saying that now 5 are left. So it's going to be 5C5. And multiply this answer with 6. And then lastly, 333. So for the first person, out of the 9, 3 gets selected times. Now for the next person, 9 minus 3 is 6. 3 have already been chosen here. So it's going to be 6C3 times. Now 3 and 3 have already been chosen. So 3 are left. So 3 and the last person must get 3 pies. So 3C3 times. Oh no, we don't multiply this with anything because 333 is just 333. So you find what this is. You find what this is. And you find what this is. And you add them. And that would be the answer, which according to the end of the worksheet is 4920. This should sum up to 4920. Okay, this was a difficult question. I mean, not a very typical question. Question 14. A team of 3 boys and 3 girls is to be chosen from a group of 12 boys and 9 girls to enter a competition. Tom and Henry are 2 of the boys in the group. Find the number of ways in which the team can be chosen. So combination. If Tom and Henry are either both in the team or both not in the team. So पहला केस कंसिडर कर लेते हैं कि दोनों टीम में नहीं है. So Tom is not in the team and Henry is not in the team. So then we have a team of 3 boys, 3 boys and 3 girls have to be chosen. And 12 boys थे, तो अब 2 निकल गए, so 10 boys हैं और girls वही है 9 girls. So इनको choose करना है. So we're going to write 10 में से 3 boys choose होने हैं, so 10C3 times 9 में से 3 girls choose होनी है 9C3. जो भी इसका आंसर आता है. Okay. And now I'm going to consider that both of them get chosen. So from the boys, Tom takes one spot and Henry takes one spot. And then the third spot can go to any one of the remaining 10 boys. So you can write 10C1 or just 10. So there are 10 contenders for this spot or 10C1 contenders for this spot. Okay. Times, sorry, either there are 10 contenders for this spot or you can write there are 10 contenders for one spot. So 10C1. Both give an answer of 10. Okay. Times 9 girls, 3 spots, so 9C3. So find what this is. 10C1, 9C3, and then plus 10C3 and 9C3. The answer should come out to be sum both of these results. So that comes out to be 10920. I'm going to make space for part B now. The back row of a cinema has 12 seats. All of these are empty. A group of 8 people, including Mary, Frances, sit in this row. Find the number of different ways they can sit in these 12 seats. Okay, 12 seats हैं. 8 people, including Mary and Frances, sit in this row. Find the number of different ways they can sit in these 12 seats if there are no restrictions. So 12 seats हैं और 8 people हैं. So we're going to write 12P8. 12 spots available for 8 people, 12P8, which is 1995840. अच्छा, पार्ट बी ना कल करते हैं. सॉरी, थोड़ा लेट हो गया और मेरी नेक्स्ट क्लास का भी टाइम काफी आगे हो गया. तो इसको इंशाल्लाह, बल्कि पार्ट बी कोशिश करो होमवर्क में कर लो. इसको इंशाल्लाह कल कंटिन्यू करते हैं. ठीक है, इस पे टाइम लगेगा थोड़ा सा. तो आई विल सी यू गाइस टुमारो. अल्लाह हाफिज. ओके. B.2. Mary and Frances do not sit in seats which are next to each other. Okay. So again, there are 12 seats available. 8 people need to occupy those 12 seats, but then there is restriction that Mary and Frances do not sit in seats which are next to each other. So one way of doing this is that you have the total combinations already from part 1. Total arrangements, not combination. And from here we subtract all the arrangements where Mary and Frances sit together. So this is 1995840 minus. Now let's make them sit together. So if Mary and Frances sit together, that's a group, and that's 2 factorial arrangements. Now let's consider this as one group. So that's going to be 2 factorial. And then there are 11 spots. 10 more spots. So that's a total of 11 spots if this is considered as a single group. So it's 11 factorial times 2 factorial from the group divided by the empty seats, because empty seats would be considered as repetition. Let's say this is empty, 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 and empty, so that there are four empty seats. So 4 factorial. So subtract this from 11 factorial times 2 factorial over 4 factorial. So whatever is the answer, you subtract these two. In fact, it comes out to be 3326400. So this is equals to 3326400. And when we subtract, that gives us 1663200. So that's the answer. Can be done in another way as well. That is that we don't want to make Mary and Francis sit together. So what we'll do, we'll first place 10 chairs here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of 12 available spots, there are 10 available. Let's say there are 10 available slots. So the arrangement for that is going to be 10 factorial times. Now, Mary and Francis cannot sit together. That means these two people now can sit either here, one of them can sit here, or here, or here, or here, and so on. So now that's the total of 11 available spots for just two people. So 11p2. So 10 factorial or 10p10 into 11p2, and then divide by number of repetitions. So like I said before, there are 4 empty seats somewhere in between. So that counts as repetition. So 4 factorial. So this would also give us the same result, 1663200. Okay. Last part is all 8 people sit together with no empty seats between them. Okay. So if there are no empty seats between them and they're sitting together, that means that we need to group those 8 people together. Let's do that. Okay. So let's make a group of 8 people because they have to be seated together. So let's group them together. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the 8 people are grouped together. That's 8 factorial. Now we're going to consider this as one person. So this is one guy, and then 8, and then 4 more seats. 1, 2, 3, 4. So that's going to be 5 factorial arrangements of these 5 seats. 5 factorial times 8 factorial divided by, there are 4 empty seats, remember? So that counts as repetition. So 4 factorial. This should give us the answer, which is 201606.